All right, so we're going to solve each equation. So here's the first one. Number 1, let's suppose we had 6x squared minus 11x minus 10 equals 0. The type of equation, knowing what type of equation you have, gives you information how you're going to solve it. So in this equation that you're looking at, what kind of equation is this? It's quadratic. For right now, you only know one way to solve a quadratic equation. And what is that way? By factoring. So you're going to solve this quadratic equation by factoring. Now on your test you just took, you're asked to factor this. So at this point, you should all be fluent with factoring, because you had to practice in a previous chapter. Now we're moving on to a new chapter that has different ideas in it, but still involves factoring. So you have to be able to factor fluently. So in this, on this left-hand side, how did you factor this? First of all, you look for a GCF. What's the GCF? 1. All right, so I can't factor anything out. So it is a trinomial. So remember, that's where you went to the two binomials. And then you factored it. So what are your possibilities that you want to try? Yeah, what's going to work is going to be the 3x and the 2x. 6x won't work in this case. So 3x and 2x, and the other side, you're going to need a 5 and a 2. You want to try a 5 and a 2? Will I put the 2 with this one? No, because that means you could factor out a 2, which meant the whole thing was divisible by 2, and it's not. So let's put the 2 here and the 5 here. The last sign is negative, so that means these signs in here are what? Same or different? Different. So the outer and the larger, the outer and the inner rather, the larger of these will take the middle sign. So the outer is a 15x and the inner is a what? 4x. When I subtract them, do I get 11? Yeah. But I need a negative 11, right? So that means that this has to be what right here? Negative, this has to be positive. Okay? Now don't forget, you do have that equal sign on the other side, so you got to say equal what? 0. So when solving a quadratic equation, you're going to first of all factor. Now what property are you going to use next? The 0 factor property. So the 0 factor property says that if you have 2 or more factors whose product is 0, then one of them has to be 0. And so remember, that's where you set each one equal to 0. So you'd say 3x plus 2 equals 0, 2x minus 5 equals 0. So notice again, you went from a quadratic equation to 2, and what are those equations that I'm pointing to? What kind of equations are those? Linear. And so to solve this first linear equation, you're going to subtract 2 from both sides, and so you get 3x equal a negative 2. And then dividing both sides by 3, what's one of my solutions? Negative 2/3. For the other linear equation, I'm going to add 5 to both sides. So I get 2x equals 5, divide by 2, and then reduce. What's the other solution? 5/2. Okay? Now, on the worksheet, I'm going to have x equal probably, and you're just going to put x equal negative 2/3, comma, 5/2. Or I could have just the word answer, and in that you could put one of several things. You could say x equal negative 2/3, comma, x equal 5/2. Or you could say negative 2/3, comma, 5/2. Doesn't matter how you write it, like as long as it looks like this. Or you could write it as a set. So how many solutions are in this set? 2. So you're going to say brace. Remember, that's how you do a finite set. So you say brace, negative 2/3, comma, 5 halves. One of the things I told you I did not want you to write it as was that parentheses. So don't write it like this. So this is incorrect that you're about to see. So don't say parentheses negative 2/3 5 halves. Because remember, the only time for right now that we use parentheses with is to indicate a point. And negative 2/3 5 halves is not one point that we're referring to. Or it could indicate an interval. So this is not representing an interval. So these two numbers here are representing solutions. And how many solutions are there? 2. So you got to write it one of these different ways. Okay? So the point being, don't use parentheses. So when you get your test back, when you had to find the domain and range of that finite set, some of you use parentheses. You were supposed to use what? A brace. You're supposed to use a brace. All right, so that was number 1.
Oh, I'm sorry.
Okay.
I'm next door.
Oh. Number 2. Hey, I've made that mistake before. Poor thing. 3x cubed minus 27x equals 0. All right. Now, this is not quadratic. Why is this equation not quadratic? What makes the first equation quadratic? Okay, I'm answering my question. What made the first equation a quadratic equation? The largest exponent was squared. What was a 2? Here, what's the largest exponent? A 3. So it's not quadratic, it's cubic. It's a cubic equation. But it doesn't matter. You're going to solve this cubic equation just like you did number 1. Or just like you did when you factored the problems on test 2. First thing you're going to do is look for a GCF. What's the GCF? 3x. Okay. So I'm going to factor out at 3x. When I factor out 3x, I get 3x times what? X squared minus 9, and that's equal to 0, right? Now I'm going to cover the right-hand side, and on your test, when you saw this part here, when you factored this binomial and you factored it like this, am I done? No, yet you could do something more with that x squared minus 9, because x squared minus 9 is the difference of 2 squares. So I can go further with that. So you would say 3x times what? X minus 3 times x plus 3. All right, so remember the difference of 2 squares. All right, but remember we are dealing with the equation now, so that's equal to what though? 0. So the first step was to factor. And remember, to factor a polynomial, you got to look for a GCF first. And there is a GCF other than 1 in this case. Now, in number 1, how many factors did you have? 2. There were 2 factors. Remember, factors are separated by products. So when I read it as 3x plus 2 times 2x minus 5. So 2 factors. Now, how many factors do you think are in number 2 at this point right here? Okay, they're really, now you can think of it as 3, but they're really 4. There are 4 factors because factors are separated as product. What you're doing when you're saying 3 is you're probably considering 3x one of them, right? But 3x is really 2 different factors. Because when I read it, listen when I read it. 3 times what? X times what? X minus 3 times what? X plus 3. So they're really 4 factors. But it is okay if you consider 3x together. All right, so 3x and then what else? X minus 3 and then what else? X plus 3. So what property am I about to use? Zero factor property. Just like we did in the first one, zero factor property. So each of those factors I'm going to set equal to 0. And then notice I went from a cubic equation to 3 linear equations. Now, when 3x equals 0, how do I get x by itself? Divide by 3. And so what's one of my solutions? 0. Over here, what's the other solution? 3. And then over here, what's the other solution? Negative 3. All right, so those are your solutions. All right, let's look at number 3. Okay, number 3, suppose you had this 2x squared minus 9x equal 2x minus 12. So 2x squared minus 9x equals 2x minus 12. What kind of equation is this? It's quadratic, so it's a quadratic equation. And the only way you know how to solve a quadratic equation is to factor. Now, at the end of the course, you're going to learn about the quadratic formula. Because not all quadratic equations are factorable, but they all have solutions. And in that case, you would have to use other methods than factoring. But these are factorable. But when I use when I solve a quadratic equation by factoring, what other property do I eventually use? Zero factor property. And in order to use a zero factor property, if you go back to the first two we've done, what was always on this side? 0. So one of the things we learned previously was that when solving a quadratic equation, it has to be in standard form. So it has to be in standard form. And so standard form for a quadratic equation looks like this: ax squared plus bx plus c equal 0. So is this equation in standard form? No. So I got to bring these two terms that are on the right-hand side to the left-hand side. So I'm going to do it in steps. Most of you can just, in your mind, know what it looks like. But I'm going to subtract 2x from both sides. Adding 2x is not going to help me, so I'm going to need to subtract 2x. Then I'm combine like terms, so I get 2x squared. What's a negative 9x and a negative 2x? 11x, and that's going to equal negative 12, right? One more step, and I'm done with regards to putting it in standard form. What's the next step? Add 12 to both sides. And so I'm going to get 2x squared minus 11x plus 12 equal 0. All right, so it's in standard form now. And then all you do is factor. So, but what's the GCF? 1's a GCF, so since this is a trinomial, I'm going to go directly to the two binomials. All right, so let's see, 2x, x, 4 and 3 I think are going to work. I need the 4 in the second binomial and the 3 in the first. The last sign is positive. That means these signs in here are going to be the same, and they're both going to be negative, right? But again, before you go on, before you set each one equal to 0, make sure you factor correctly, which is what you should have done in your test, because you had enough time to do that. What is the outer? Negative 8x. What's the inner? When I add them up, do I get a negative 11x? Yeah. All right. So first thing I did was I factored. Now what's the next thing I'm going to do? Use the zero factor property. And so when I use the zero factor property, notice I have how many factors right here? 2. Their product's equal to what? 0. So one of them has to be 0. So you set it each one equal to 0 because both of them have variables in it. Each of those factors have a variable. And so notice I went from a quadratic equation to 2 linear. So to solve this linear equation, you're going to add 3 to both sides. And so you get 2x equal 3. Then you can divide both sides by 2. And so you get x to be 3/2. Over here, what's x equal to? 4. All right, so that's number 3. All right, let's look at number 4. Suppose in number 4, I had this. We had x cubed minus 4x squared minus 5x equals 0. Now again, notice this is not quadratic. It is cubic. But you still have enough information from what we've learned to be able to solve this equation. What's the first thing you're going to do? GCF. You're going to try factoring. You're going to try solving this by factoring. And so what is the GCF? X. You can say x times and then x squared minus 4x minus 5 equals 0. Make sure you say equals 0. But on your test, if you were to, and you could have had this on your test, this factoring. So when you factor this right here, would you have stopped here? No, because you know you can do more with this trinomial. So in your test, you should have factored further, and then that would have given you what? X, 5 and 1. The last sign's negative, so these signs are going to be different. And the larger of the outer and the inner will take the middle sign. So the 5 has to be negative and the 1 has to be positive. But again, these three factors, what is their product equal to? 0. So their product equals 0, then one of them has to be 0. So you set each one equal to 0. And you solve each of those equations. So first of all, x is already by itself, so one of my solutions is what? 0. What's the other solution? 5. And what's the other solution? Negative 1. Okay? All right, so those three numbers will make the left-hand side equal to 0. And you could check, let's just quickly check 5 if you want to check one of them. Let's check and see if 5 actually works. So always back to the original, because you could have messed up somewhere in this process. So always go back to the original. So x cubed minus 4x squared minus 5x equals 0. So where we see the variable x, what do you substitute? 5. So I get 5 cubed minus 4 times 5 squared minus 5 times 5. And I want to see if that's going to equal what number? 0. Well, on your calculator, what's 5 cubed? 5 times 5 times 5. 125. Minus, what's 5 squared? And what's 25 times 4? 100. And then what's 5 times 5? All right, so here's what I have. I have 125 minus 100, which is what? 25. And what's 25 minus 25? 0. Okay? All right. Number 5. Now, number 5, you're going to see one like that on that worksheet that's due next week. X plus 3 times x minus 8 equal 5x. You didn't have it on this one. So the problems you turned in today look like numbers 1 through 4. But next week, you are going to have a problem in that worksheet that looks like number 5. Now, be a little bit careful. On the left-hand side, it is factored, right? Yeah. You have two factors on the left-hand side. What are they? X plus 3, and what's the other? X minus 8. Are you going to set each of these equal to 5x? No. Good. Because remember, in order to set those factors equal to a number, that number must be what? 0. Hence the phrase, the zero factor property, a product that's equal to 0. But that's not the 0 here. What is that? 5x. So we got to think about how we're going to approach this. I can't say x plus 3 equal 5x, x minus 8 equal 5x. So if I'm using the zero factor property, it's got to be 0 on the other side. So, all right, so she wants to subtract 5x. So let's see what happens if you subtract 5x. I get this. X plus 3 times x minus 8 minus 5x equals 0. So I have 0 on the other side, right? But what are my factors? Do I have a product of factors that's equal to 0? Do I have that? So you're telling me that when I read it all out, it's going to be some factor times some factor times some factor times some factor times some factor equal to 0. Yeah, let's read it. How do you read this? You're going to say what? X plus 3 times x minus 8 minus 5x. Is that times 5x? No. So what you have at this point is not going to help you. Okay? Because that's not a factor right here. Those are not a product of factors. X plus 3 times x minus 8, but that's not a times negative 5x or times 5x. That's what? Subtract 5x. Any ideas?
Do we need to get it to standard form?
You need to get, okay, so good idea. What he wants to try and do is to get this problem to look like in standard form, meaning to look like this.
Oil it.
Very good. So what I would have done first is what he said. He said, look, if you look on the left-hand side, you're multiplying two binomials. One of the things we reviewed from a previous course earlier in the semester was foiling. And so if you multiply these two binomials out, you get x squared. What's the outer? Minus 8x. What's the inner? Plus 3x. What's the last? Minus 24. And that's equal to what term? 5x. Combining like terms on the left-hand side, I can combine the x terms here. I get x squared minus 5x minus 24 equal 5x. And now that kind of looks like one we did a while ago, and that was number 3. Remember number 3? Where we had to put in standard form? So what is it I got to do here? Subtract 5x. And I'm going to go ahead and align my like terms. So in a combined like terms now, remember what you do one side, you do the other. So notice I have subtract 5x on both sides. Combined like terms, I get x squared minus 10x minus 24 equal 0. So now it is in standard form. And so what's the next step? I have a quadratic equation. So you're going to factor. The GCF is 1. So you can go directly to the two binomials. And so x squared, the coefficient is 1, so that's the easy kind. So x, 12 and 2, I think. And the 12 has to be negative, and the 2 has to be positive. And so one more step or two more steps and you're done. What's the next step? Set each factor equal to 0. So x minus 12 equals 0. X plus 2 equals 0. So notice I went from a quadratic equation to two linear. So what are your solutions? Positive 12 and negative 2. All right, so positive 12 and negative 2. All right, let's look at one more, and that's this one. Okay, number 6, you have this. You have 4x minus 3 squared equal 0. 4x minus 3 squared equal 0. All right, so you want to solve this quadratic equation. Now, I said it was quadratic. It is quadratic. How do you know it's quadratic? Because if you look at this, 4x minus 3 squared means what? 4x minus 3 times 4x minus 3, right? So if I look at this, I get 4x minus 3 times 4x minus 3. And if I FOIL it, what's 4x times 4x? 16x squared. Now, I'm not going to FOIL it, but in your mind, you do see it's quadratic, though, right? Because x times x is x squared. So you are going to get a square term as the largest term. But notice how I wrote this. I wrote this as 4x minus 3 times 4x minus 3, and that product is equal to what? 0. So did I have to factor? No, because it was already factored, right? Do y'all see it was already factored? So it kind of looks like number 1 on that worksheet you turned in, where they were already factored, which is this right here. But what do you notice about those two factors? Same or different? They're the same. They're the same. So just like when you did the domain and range on that test, when you had that finite set, if it repeats itself, you only list it once. So these two factors repeat, only list it once. So 4x minus 3 is going to equal what? 0. So you solve for x. So you're going to add 3 to both sides. So 4x equals 3. Divide both sides by 4. And so what is your solution?
3 over 4.
3 divided by 4, 3/4. In all of the, if you go back and look at all the quadratic equations, those that were quadratic. Not number 4, because number 4 is not quadratic, number 4 was cubic. But if you go back and look at all your quadratic equations, how many solutions were there? There were 2. How many solutions do you see here? 1. But it repeats, because it occurred how many times? Twice. So next semester, you're going to learn about something called the double root. So there's a double root. So root means the same thing as solution. So this is a double solution, double root. Because it occurred how many times? Twice. We only list it once. Now, in terms of graphing, it does mean something. Next semester, when you graph these. So it all has to do with x-intercepts. When you graph the quadratic functions, your solutions are actually your x-intercepts. You're going to see that next semester. All right. Now, you don't use the word double root. You just say x equal what? 3/4. All right. Just notice that this quadratic equation only had one solution. One distinct solution. It just repeated itself. Okay. So I think on the worksheet that's coming up next, there is one like this as well. So 5 and 6, just make sure you look at as you do the next worksheet. Okay? All right, so that takes care of this.